Hey class, so today we are going to start to talk about logarithms. Some of you, if you had honors algebra 2, you might have done stuff with this a little bit, but for most of us, I think this will be pretty new. So last class we worked on exponential equations. A logarithm is the inverse of an exponential, okay? So it's the inverse of an exponential function, which means that a logarithm helps us solve for an unknown exponent. So that's really what we're going to look at here with a logarithm, okay? So if you think about inverse functions, we've talked about them in the year previously. X squared and the square root of x. Those are inverse operations. If you say y equals x squared, if you graph that, and then y equals the square root of x, you get inverse functions of each other. Same with x cubed and the cube root. We looked at sine, and there's also sine inverse. We can undo that function. Well, here, y equals b to the x, that's an exponential function. The logarithmic function, which is its inverse, is taking the base of your exponential, and it becomes the base of your logarithm, and logarithm is abbreviated log, just a log. If you get further into this topic, we won't really have time to do that this year, but there's something called natural logs. You use that in science when you talk about radioactive decay and carbon-14 dating. And that's log with a base of the number e. E is kind of like pi, like 2.7. We've looked at it briefly this year and when we were doing the sequences and series. That's abbreviated ln. So you might see both of those buttons on your calculator. We are not going to focus on this for now. We're just going to focus on the regular old logs, okay? So you can see that they're inverses of each other. They're using the same values. The base of the exponential is the base of the log, and then what the answer is here, that becomes the input into your function. That's what we're taking the log of, okay? And the exponent becomes what we're looking for. It becomes the answer, right? So what we're doing is we're solving for this exponent. Now, I've made a lot of lines for you, so hopefully you can follow all of that. So we're going to do a little bit of work on the calculator today, but just so you're clear here, the log button on your calculator, most of them won't say this little 10 at the bottom. They'll just say log. If you just see the word log, that implies that it is a base 10. And this particular calculator on my iPad, I can push the shift button and I can also use log base 2. So that's actually really helpful. Over here you see ln that I was talking about, the natural log. But again, we won't use that really today. So one of the things that we're going to talk about today is how to go from a logarithmic form of an equation to an exponential form, because sometimes, depending on which form we're in, it can be easier to solve the problem. So here, the base of our logarithm is this small subscript here. The base of a logarithm is also the base of the exponential. So if I'm going to write the exponential equation, the 3 that's acting as the base goes down first, and its exponent is the answer, right? That's what we were solving for. And in this case, it's saying the exponent is 5. And then what that would be equal to is what you're taking the log of. So when we rearrange the logarithmic statement to an exponential statement, it's saying 3 to the 5th equals 343. Now I want you to think to yourself for a minute, well, does 3 to the 5th actually equal 343? Yeah, it does. So sort of a way to mentally check, if you would flip-flop these numbers and said, okay, 5 to the 3rd equals 243, well, if you actually do 5 to the 3rd, you're going to get 125, right? And that's not what we want, okay? So we can change forms just like that. Let's maybe practice just one more quickly. Let's say I have log base 2 of 8 is equal to 3. Well, if I want to rewrite this, the base of the log is the base of my exponential. What's on the right side of the equal sign is the exponent, so 2 to the third. And then what you're taking the log of becomes the answer. So 2 to the third is equal to 8. Well, is 2 to the third equal 8? Yeah. So again, it sort of mentally checks. What a logarithm really is doing, though, is if you sort of read this statement here, it's saying if 2 is the base, what is the exponent that gives me an answer of 8? So a log is really asking, what is the exponent? That's what you want to keep thinking to yourself, okay? Let's reverse that. So if I give you an exponential equation, let's write it as a logarithm. So log is always going to come first, and then we want to know the base of our log. Well, the base of the exponential is 6, so the base of the log has to be 6. And then the exponent and the answer sort of swap places. That's how I like to think about it. So we're doing log base 6. It would be of 1 over 216, and that's equal to -3. That's how we could rewrite that. Again, if you recall, we did a little bit of exponent review the other day, but I don't think I touched on negative exponents. But remember, negative exponents just make things into the reciprocal. So if you see a fraction, that's definitely caused by a negative exponent, okay? Let's do another practice one like that. So let's say 5 to the third power equals 125. Let's turn that into a logarithm. Well, we're going to start with the word log. The base of the log is the same as the base of your exponential. So log base 5. And then we're going to take the log of 125. And the answer would be 3. Because the exponent on 5 to give us 125 is 3. Okay? So that's the first step of practice here. I encourage you to pause the video, try some of those practice problems. Do not do the whole page. I just attached those full worksheets, but pick 3 to 5 problems, try them, make sure you got it down, and then pick back up with the video and let's move on to the next topic. The next topic being evaluating a logarithm. So this time they're not giving me something on the other side of the equal sign. I have to figure it out. One of the easiest ways to do that is to rewrite it as an exponential. And I'll also show you in a minute how to do it with your calculator. But we're going to rewrite this as an exponential equation. So if it's log base 4 of 64, it's equal to something, I don't know. So right now, I'll make that a question mark. It could be an x. You can use a question mark, whatever you want. So when we change it into an exponential form, 4 is the base, question mark is the exponent, and the answer is 64, right? So now you have to figure out 4 to what power gives me 64. Well, 4 squared is 16, and if I multiply 16 by another 4, I get 64. So 4 to the third is equal to 64, which means question mark is equal to 3. So the log base 4 of 64 is actually 3. All right. I'm going to skip that one for a second. It's a little trickier. This one is log base 3 of 3 squared. And again, I'll set it equal to a question mark. If I change this into exponential form, the base is 3. The exponent is the question mark. And then it should equal this whole thing 3 squared. Well, if 3 to the question mark equals 3 squared, then question mark has to equal 2, right? That's something we did the other day. So the other piece that we know about exponential and or logarithmic equations is that if you have the base of your log and the base of the exponential are the same thing, they cancel each other out and just leave you with the answer, okay? So log base 3 of 3 squared would be 2, just like log base 4 of 4 to the 7th would be 7, okay? Log base 4 of 1 over 16 Again, set it equal to some unknown. You can use x instead of question mark. I'm just having fun writing question marks right now. So if I rewrite this, it's 4 to the question mark equals 1/16. And when you see a fraction, do not stress out. Just focus on this bottom value, the denominator. Well, 4 squared is equal to 16. I know that. But if I want a fraction, if I want the inverse, what I need to do is make that exponent negative, okay? So 4 to the negative 2 power is 1/16. So then I know that the log base 4 of 1/16 is negative 2. Let's go back to this one that I had, log base 27 of 81. So if I rewrite this in exponential form, 27 to the what power gives me 81. Well, I know that the 27 to, we're not going to be able to raise that to any power to get to 81. But I do know that 27 and 81 can both be written with a base of 3, right? 27 is 3 to the third, to the question mark, and 81 is 3 to the fourth. And then just like we did last class, when you have a power raised to another power, you multiply those. So 3 times question mark would be 3 question mark. Oops. Should we use x instead of question mark? I don't know. We're too far in now. So 3 question mark would have to equal 4, right? And I can do that because the bases are the same, right? So they're almost, we can ignore them, just set the exponents equal. So then the unknown exponent is 4/3. So log base 27 of 81 is 4/3. Another way you can think about that is the cube root of 27 is what gives us 3. And we know 3 to the fourth power is going to give us 81. Well, remember radicals give us fractional exponents. So this is really 27 to the 1/3 to the fourth. And then multiply, when it's power to a power, we multiply. So it's 27 to the 4/3, right? That's a sort of a different way of going around it. But either way, you get that answer, okay? So again, I encourage you to pause the video here and try some of the practice evaluating the logarithms. Let's now use the same concept to help you solve the equations, okay? So these are all going to be pretty basic ones. We're not throwing any logarithmic sort of tricks and advanced things at you yet, but we're just going to still use the same process, change it into an exponential, and solve for x. So here I have log base 2 of 2x is equal to 3. We're trying to solve for x. So my first step would be to rewrite it as an exponential equation. So 2 to the third is equal to 2x, right? Base of your exponential, this is your exponent, this is the answer. Well, now simplify. 2 to the third is 8. And then divide by 2, well, x has to equal 4, okay? You might have also been able to figure that one out in your head, right? We know that this is the base of the exponential, this 2. 3 has to be the exponent, so we need this thing to equal 8, right? Well, 2 times 4 is the only thing to equal 8. One other type of problem like that is instead of just having a log on one side of the equation, as you see we did here, there's only a log on the left-hand side. There's nothing, just a number, a constant on the right. We have logs on both sides of the equation. And the key here is these logarithms, in order for you to cancel them, they have to be the same. Same base. Okay, so you have log base 2 on the left and log base 2 on the right. Well, just like when we had 2 to the fifth equals 2 to the x minus 1, right? When the bases are the same, we can ignore them and set the exponents equal to each other. Well, we're going to do the same thing here when our logarithm has the same base, okay? So we're going to cross those out because if you're taking the log with the same base on one side and the log with the same base on the other side, then what you're actually taking the log of, this and this, that actually has to be equivalent, right? So if it's the same on both sides, we can cancel it out. Even though we're technically not canceling it, we're just removing what we're taking the log of, because it's not multiplication, right? It's an actual function. So x plus 17 and 3x plus 23, those are the inputs. But it sort of looks like we're canceling it out. So if that helps you keep it clearer in your mind, try that. And then we just have to solve this equation. So taking away 3x, so negative 2x is equal, plus 17 is equal to 23. Take away 17. Negative 2x is equal to, and that's going to give us 6, divide by negative 2, and x is equal to negative 3. So if you substitute that back into your equation, then that would say log base 2 of, well, negative 3 plus 17 is 14, has to equal log base 2 of, now it's 3 times negative 3 plus 23, which would be log base 2 of negative 9 plus 23, 14. So it checks out. One crucial thing to remember is we can't take logs of negative values. So if you were doing log base 2 of negative 5, there's no answer for that, okay? Because 2 to some power is, oh, actually I lied. I'm having a momentary brain cramp, but just ignore that last statement. Keep on checking, and you're doing great. So let's look at one last thing here. Mrs. Levenseller's losing her mind at the end of this COVID, I think. Again, pause the video. If you want, go try some of the solving equation ones. They're the same base on both sides. They cancel. If you're rewriting it as an exponential, if it's only a log on one side, okay? So, lastly, if we get stuck evaluating these, we can always use our calculator, okay? So, the log in our calculator, like I mentioned before, if you just see the word log, it's really log base 10. And that's sort of like the most general log. There can be other bases, like we've looked at log base 2, log base 3, but log base 10 is the most basic one, and so that's the one you have the button for. So let's say we want to evaluate log base 10 of 3, or it might just say, your problem might just say, what's the log of 3? Okay, well, we're trying to think 10 to what power would give me 3. That's a pretty hard answer to come up with because it's not a nice, clean integer or rational number. So instead, let's go to our calculator. Okay, so we're going to go here, and I'm going to hit, on this particular calculator, 3 and then log. And you're going to get these really, long decimal values, sort of like we did with trig. That's perfectly fine. You're not wrong. And when we talk about logarithms, try and keep 4 decimal places to keep it exact. So 10 thousandths place is what we're rounding to. So this would be 0.4771. Now that is not a number I would come up with on my own, right? If we don't have a nice tidy one that says base 10, we can still use our calculator to do that. Some of you have those Casio calculators and you can actually change this base number on your Casio. But for most of us, we have to use what's called the change of base formula, okay? And the change of base formula says if you have a log with the base of a and you're taking the log of b, then you can rewrite it with log base 10 so that you can put it in your calculator. So you're going to take the log base 10 of b and you're going to divide it by the log base 10 of a. and it will give you the same answer, okay? So the log base 5 of 21 is going to really be in our calculator. Well, first of all, this is asking me 5 to what power gives you 21, okay? Well, I have no idea. So, right, 5 squared is 25, so it's got to be below 2, but I don't know exactly. So I'm going to rewrite this with my change of base formula. So we see what you're taking the log of here, that goes on top, right? So it's log of 21 divided by, and then what the base of the log was, is what you put in the denominator. So divided by log 5. So if I go to my calculator, we're going to do 21 log divided by 5 log and hit equal. So this time we get 1.8912, or sorry, 1.8917. Okay, so again, if you get stuck with the evaluating, this always works for you, even if it's going to come out to an integer. It's just sometimes faster to do it without the calculator, but this will work every time. So go ahead and give those practice problems a try.